What up, geometry students? Let's review the problem types we saw from this unit where we are doing geometric situations, but with algebra in the coordinate plane, using equations for lines or parabolas. First two questions deal with these regions contained by these three graphs: a horizontal line y equals 4, a vertical line x equals 8, and this line 2x plus 3y equals 10. You could solve this equation for y to see what it kind of looks like, knowing that it's going to have a negative slope. But what we realize is that with a horizontal line and a vertical line, we probably want to just find the points where we intersect. Now, this is the x equals 8. This is the y equals 4. I'm assuming this is what's going to happen. I can't assume, like maybe we like come up here or something like that, but we'll have to look at it. This is the point 8,4 when x is 8 and y is 4. Let's find these 2 points. So we need to figure out on this equation what the other half of the point on the line 2x plus 3y equals 10 equals. So when y is 4, what is the x that goes with that y? So I'll plug in 4 in for y. I get x is negative 1. When I solve, now that is an x that goes with this y. They are a team. They work together. You can't just have one without the other. It's the point on the line that intersects with y equals 4. Now I got to figure out this point down here where x is 8. If I plug in 8 in for x, I get 16 plus 3y equals 10. I get 3y equals negative 6. I get y equals negative 2. So I get this point 8, negative 2. Remember, they go with each other. Now we see we're trying to find an area. We see we have this right triangle. So we need to find this length, this vertical length. It's a y top minus a y bottom, or you can just kind of figure it out. You got to figure out this length, which will be a right minus a left x. I go from 8 to negative 1. This is going to be 9. So the area is 1/2 base times height divided by 2, a half of the height times base. So it'll end up being 27 after you do that work. All right. Same here. We got this 1/2 x plus 8. So probably like that. Maybe my region looks something like this. I don't know. I don't know. I'm going to kind of know I got y equals 2. I got x equals negative 4. What is that going to look like? So let's figure out the points. If x is negative 4, y is 1/2 times negative 4 plus 8. So that's going to be 8 plus negative 2, which is 6. Okay, so that's up here. And then if y is 2, what is x? Subtract. How do you get rid of the 1/2? Multiply by 2. X is negative 2. Oh, we're all the way over there. So this is just like, I'm going to have to kind of zoom out here and be like, x equals negative 4 is here. This graph goes like this. This is the point here, there. This is stuff you just have to figure out. This is the point negative 12, 2. This is the point negative 4, 6. This is the point negative 4, 2. There's your triangle. Base length, you go from negative 12 to negative 4. That is going to be 8. Height, you go from 6 to 2. That's 4. So we'll have an area of 16, half of the rectangle that surrounds it. Cool. Then we have these questions where we have these 2 different regions and we have 2 different lines that intersect. We need to find the intersection and find the area. This purple line is very important. We know the purple line is negative 2x plus 10 because of the negative 2x will decrease. Also, you can see y equals 1/2 x has this point 0, 0. I will need this point when x is 0. When x is 0, I can see that my y is 10. You can fill out a little chart here for that. When x is 0, y is 10. Here, this is when y is 0. When y is 0, I can kind of see that x has to be 5, so that we have negative 2 times 5 equals 10. Or I get negative 10 equals negative 2x. I get x equals 5 after dividing. 5, 0. And then I have this other very important point where the two lines intersect. Two lines will intersect when their y coordinates will equal each other for a certain x coordinate. We will find the intersection by setting them equal to each other. And add two x's to both sides. You know what a student did that made everything better? Like sometimes you don't have to deal with fractions. One of my students said, like, gosh, get rid of this 1/2 by multiplying by 2. I'm like, go ahead and do that. But if you do it correctly. Right? And then you get 20 equals 5x, and then you get x equals 4. Very easily done. Sometimes when you work with fractions, it'll be harder. If you added 2x, you'd get 4 halves plus 1, which is 5 halves x, and then you have to multiply by 2 and divide by 5, and you'll get the same answer. But isn't this maybe like a little bit easier? Maybe we should be teaching that. Anyways, we have this 0.50. Now we have this 0.4. Well, when x is 4, we can see y has to be 2. 4, 2. Great. Now, what is region 1? Well, we need to figure out the base, and then this height, this length, is like the height of the rectangle. Triangles are always half of the rectangle that surrounds it. Oh, I forgot to include that other type of problem with the 3 points. Darn it. We'll put it on the test. See if you guys can remember it. From 0 to 10, this length is 10. From, what is this length? Well, it's not 0 to 2. It's actually 0 to 4. It's this x length. It's the x minus the x. So this is 4. So this rectangle is 40. This triangle is 20. This length is 5. This height of this triangle is 2. So that means this region is 5. The rectangle that surrounds it is going to be a 5 by 2, 10, half of that, or 1/2 base times 10. Cool. This question. We have the rectangle that's created with this line. As x changes, the rectangle will change when x is 3. So let's do this. When x is 3, let's figure out what y is. All right, so y equals negative 2/3 times 3 plus 10. So that's going to be 8. All right. If this is 3 and this is 8, so it's probably like right here. This is 3 and this is 8. This is 16, this is 9, that's 25. The perimeter is 25. And the area is 24. If x is 6, then y equals negative 2/3 times 6 plus 10. 6 times negative 2 divided by 3, or 6 divided by 3 is 2. This is 4, and this is going to be 6. Okay, so this will be 6, 6. So we have this square, 6 by 6, whose perimeter is 4 6s. Ooh, cool. Perimeter is decreasing. The area is 36. But what the purpose of this unit is to like be able to turn geometric situations into algebraic expressions, into evaluate them. my perimeter at any x value will be this x plus this x, and then these negative 2/3 x plus 10s, and these negative 2/3 x plus 10s. So I have 2 of my x's and 2 of my negative 2/3 x plus 10s. My perimeter is 2x plus negative 4/3 x plus 20. How do you multiply fractions? I have 2 of these 2/3 multiply straight across. Now, if this is 2, this is 6/3, and if I have 6/3 x plus negative 4/3 x, I get my perimeter is 2/3 x plus 20. Great. Well, that means my perimeter will start at 20 when x is 0. My perimeter will then continue to increase until I get all the way at the end. Well, like we should realize that we're kind of stopping when this equals 0. That's when multiply everything by 3. How about that? That's what x is 15. So we're going to go all the way from 0 to 15. And if we go all the way to 15, we are going to have a perimeter of 30. 15 divided by 3 is 5. 5 times 2 is 10. So this is 30. So we can see that our perimeter starts at 20, goes to 30 over the course of our lengths being 0 and 15. If we do our area, it'll be the base times the height. Cool. Well, we can kind of see / we know that the area will be 0 when x is 0, and the area will also be 0 when x is 15. Cool. However, we realize that this is a quadratic, which means it's going to come up and come down. It's this negative 2/3 x squared. Well, where is the area going to be the maximum? It's going to be at this vertex. Well, the vertex is when we are smack dab in between our two zeros, and that's going to be at 7.5. Now, what is the area? Well, the area is going to be 7.5 times negative 2/3 times 7.5 point plus 10. And I'll get a calculator out to do that. So it is 15 halves. Yeah, it's not gonna be nice, but I'll just do it with 7.5. 7.5 times negative 2/3 times 7.5. I just divide to two fractions plus 10. 37.5. That's the idea. Technically, when x is 15, the perimeter is the greatest. When x is 7.5, the area is the greatest. Cool. Now, when x is 15, we get this idea of like a long rectangle with no height, but it's like, don't worry about it. The perimeter will always increase. Go ahead and say 15, even though like the rectangle doesn't exist. It's like we're going to be approaching 15. Yeah. Same deal. I'm going to jump to this because if I do this, I can do this. Like if I get my perimeter expression and my area expression, I can figure out what the perimeter and the area is at 1 and 2 without using numbers. And this is kind of like what we wanted you to get to. It's like, well, the perimeter at any x will be x and then twice and negative 2x plus 8 twice. So I'll have 2 x's plus 2 of these negative 2x plus 8s, which means I'll have 2 x's plus negative 4 x's plus 16. My perimeter will be minus 2x plus 16. Now we know that when x is 0, this is where I start. And you can figure out when this has a y coordinate of 0, that's going to be when x is 4. 4 is where I end. That's where the rectangles are going to end. So I kind of want to look at my perimeter from 0 to 4. Well, if I plug in 0, I get 16. If I plug in 4, I'll get 8. And I realized that this perimeter of this situation will decrease consistently. It's a linear situation with this rectangle. Cool. Which means I could use this equation for the perimeter at x equals 1. Plug in 1, I see that we got 14. If x equals 2, plug in 2, I get my perimeter is 16 minus 4, which is 12. Great. And I can see that my perimeter is going to be the greatest when x equals 0. The perimeter is 16. That's my greatest thing. Now it's like, well, you don't have a rectangle. We're just going to say we do. It's like heights of 16 or heights of 8, width of 0. We'll call that. But we're maybe thinking about it approaching 0. And let's do the area. Well, that's going to be the base times the height. So x times negative 2x plus 8. We know this will equal 0 at 0. We know this will equal 0 at 4. This is the start and the end. We know that the area is 0 because in this situation we have no width. In this situation we have no height. But then we realize that at 2, my area is going to be the max because this is the graph of a quadratic. And we realize that up there is the vertex. The vertex is smack dab in between your zeros. And we can find the area at 2. If I plug in 1, I got negative 2 plus 8, which is 6. If I plug in 2, I'll have negative 2 times 4, which is negative 8 plus 16, which is 8. So the max area is going to be 8 at x equals 2. Switch it to the quadratics. I gave you 3 of these. First one, I'll do it with numbers, and then I'll do it vertical distance at any x, and then we'll find the zeros and graph the vertical distance, d. Okay, how do you find the vertical distance between the 2 points? You want your y coordinate on your top and your y coordinate on your bottom, and the vertical distance will be the y at your top minus the y at your bottom. Now, which one is which? Well, you got to know that negative x squared is this curve, and that the line negative x minus 8 is that guy there, that blue guy. And let's say we want to figure out this vertical distance at x equals 1. Well, we need to find the y coordinates, which means we need to find f of 1. We need to plug in 1, we'll get 3. We need to plug in 1, we'll get negative 9. Now, if you don't know how to plug in 1 and get 3, this negative x squared means you're taking 1, squaring it, and then taking the opposite of it, and then adding 4, which gives you 3. Now, 3 minus negative 9 is 12. Or you could just be like, oh, from negative 9 plus 12, you get 3. Okay. All right, when x is negative 1, a little bit more complicated. Negative 1 is being squared and then taking the opposite of it. I guess this is good practice for plugging in negative values. So we actually still get that point, negative 1, 3. And this point here, if I plug in negative 1, I'll take the opposite of negative 1 and subtract 8. So that becomes positive 1 minus 8. This is good practice, which gives you minus 7. So I go from minus 7 to 3. I subtract the negative, and I can see that my distance is 10. But the whole purpose of this idea in this lesson is to say, well, at any x on this equation, our y is this. At any x on this equation, our y is this. What would be the expression for the vertical distance at any of those x's? Well, it'd be the y at the top minus the y at the bottom. Here's the y at the top minus, in parentheses, the y at the bottom. You have to subtract this entire y at the bottom. Now, when you subtract these negatives, it becomes plus a positive, plus positives. And we realize we get negative x squared. This is plus an x, and then 4 plus 8 is plus 12. Great, I just simplified it. I added the 4 and the 8, and I got that. This could be used. If you plug in 1, you get the distance of 12. If you plug in negative 1, you'll get negative 1 plus 12, which is 10. Great. But how else could it be used? Is we could find the zeros. We could take this and set it equal to 0. That way we can graph this distance equation we created, and we can see where our distance is going to be the greatest. Well, I'm going to factor out a negative 1 so that I have this positive x squared, which I know factors to be an x plus a number times an x plus a number. The two numbers are negative 4 and positive 3. Okay, that means my zeros are at positive 4. That's when x plus negative 4 equals 0. And negative 3, that's when x plus 3 equals 0. X equals 4, x equals negative 3 are zeros for my distance. Where is my distance going to be the greatest? It's going to be smack dab in between those two values at 0.5. What is the distance? I mean, it actually just asks you for the x location. But if I ask you, what is the distance? It'd be the opposite, and I could just plug in 0.5 into any of these versions of my distance equation. I get negative 1 times negative 3.5 times positive 3.5, or I get 3.5 squared. And 3.5 squared is a number. 12.25. So when x is a half, my distance is the greatest, which is 12.25. It's like an xy, but it's an xd. Right. Some more. What we realize is we can skip this first two steps if we want to. We can go straight to the third one and then be able to fill out the first two. Here we can see this blue line has an x, y, and this red curve is going to be the x squared minus 6, the x parabola. The top minus the bottom is a little bit different. It's 2x minus x squared minus 6x, which I'm going to simplify by subtracting the opposite, adding the opposite. I'll take the 2x and the 6x, and I get 8x minus x squared. Or I could have negative x squared plus 8x. And now what we realize is like this is the distance for any x. So the distance when x is 1 will be 8 minus 1, 7. Go ahead and plug in 1 if you wanted to. If you plugged in 1, you got 2. If you plugged in 1, you got negative 5. What's the distance between negative 5 and 2? 7. Look at that. Like, this is math. Plug in 2. What do you get? Well, my distance equation says I'd get 8 times 2, which is 16, minus 2 squared, which is 4. I get 12. Hooray. Well, you could have done the same thing. Plug in 2. You get 4. Plug in 2. You get 4 minus 12, which is negative 8. What's the distance between negative 8 and 4? 12. Bam, subtract the values. Great. But didn't have to do that because we have the distance equation. And what's great is when you take your distance equation and you find the zeros of it, well, in this situation, since I just have x's, I don't have to do the number puzzle. I could just factor out an x, see what are the x's that make this 0. Okay, 0. What is the x that makes this 0? Okay, 8. Or you could solve the equation 8 minus x equals 0. Okay, well, like obviously x has to be 8, but add 8 and you get x equals 8. Great. 0 and 8 will be the zeros of my distance. My distance is this negative x squared equation. 4 must produce my biggest distance, and my distance at 4 is 32 minus 16, or 4 times 4, which is 16. When x equals 4, my distance is 16. My last one. This was the hardest one, but we can do it. Which one's the top? Which one's the bottom? Negative x squared. If y equals x squared's graph, 1, 1, 2, 4, 3, 9, 0, 0, negative 1, 1, negative 2, 4. Like if y equals x squared looks like this, y equals negative x squared would take all of those y coordinates and flip them. Okay, so f of x is that graph right there. G of x is that graph. I'm going to just go straight here and say my top y minus my bottom y gives you what you're looking for, your vertical distance. Add a negative, add a positive. Interesting. That means I have negative 1, negative 2 x squareds. That means I have a positive 6x and I have a positive 8. All right, cool. But that's going to be the distance at any value, which means the distance at 0 is 8, which means the distance at 1 is 8 plus 6 is 14 minus 2 is 12. What are the zeros of my distance equation? Well, I have to somehow solve this equation, and we like to give you questions that you can solve by factoring. I'm going to factor out a negative 2. I got a positive x squared, a minus 3x, and a minus 4. Ooh, leave the negative 2. It's not getting in any way. It's not going to give you any different solutions. It's just part of your distance. What are the two numbers that add? You should know this. You're not memorizing this because you understand how to distribute. That when you distribute x plus a number times x plus a number, you'll have x squared, x times a number, number times x. Oh, those two things will be added to get the amount of x's. And then the number times the number gives you just the number. So the two numbers multiply to get this, add to get those. Those two numbers are negative 4 and positive 1. Now, don't worry about this negative 2. It's not going to affect anything. When I plug in 4 for x, this goes to 0, which means everything's 0. When I plug in negative 1 for x, this goes to 0, which means everything goes to 0. Negative 1 and 4 are the zeros of my vertical distance equation. How do I get the vertex? Well, I add 5 to get all the way there. Why don't we go halfway by either adding 2.5 or subtracting 2.5? If you subtract 2.5, you get 1.5. If you add 2.5, you get 1.5. Or you can average these two values, find the midpoint. You get 3 halves or 1.5. Great. There's my vertex right there. Now, what is that length? Well, you have to find the distance at 1.5. I would use a calculator to do that. It ends up being negative 2 times 4 times 1.5 is 2.5. And then this is 2.5 as well. So negative 2 times 2.5 times 2.5. So that's 6.25. I'm thinking it's 12.5. Great. So when x is 1.5, my distance being 12.5 is going to be the max distance. All right. That's a good review of everything. And This will be most of your test questions like this. All right, peace.